Flack math! Give me some math and I'll give you some flack. Flack math!
All right, lesson 13 is where we are in Algebra 1. You ready? So we're talking about more symbols of inclusion. You guys remember all the different types of symbols of inclusion? I think you could probably name 5 different types of symbols of inclusion. Nathan?
Brackets, parentheses, braces, absolute value.
And then one more that we learned last week.
Commas.
Well, not commas.
Punctuation.
Some type of punctuation? Not punctuation.
A division bar.
Yep, division bar. So it's implied, like it's not really tempting to go beyond that symbol of inclusion, but a division bar says you have to do everything on top first, then everything on the bottom, or vice versa. Then the last thing you do is that division problem. So that's technically a symbol of inclusion as well. All right, so let's get our math juices flowing. Oh, this is good. This is good. What's that equal? See if you can do that. What's that? You have an answer already?
Yeah.
What'd you get? 72? It's not what I got. And I know I'm right on this one, unless I wrote the problem down wrong.
Last time.
Yeah. No, I'm right. You're wrong. Try it again. You guys got an answer? Audrey, what'd you get? 78? Anyone else get 78?
I got 98. I got 98.
Okay. Well, I got 78. So let's see if Audrey and I are right. We probably are. So, check it out. What are you doing first? So you got parentheses, but you got parentheses inside of parentheses. So you got this problem, so you can ignore everything outside of those bracket or those braces for now, and then inside the braces you got this math problem. Well, this math problem says do parentheses first. You got these brackets, so you can ignore everything outside of there. Well, inside these brackets you got another math problem. Well, this says do these parentheses first. So here's what we're doing first. So the innermost parentheses first. So everything else I'm just going to write down the same, and then just do this math here. So that is -5 times -3 minus 5. Is that what you guys got so far? No, what'd you do, Nathan?
And then -5 minus -3, and then times 2.
Oh, yeah, little brain fartage. That happens. Okay. All right, so now we're just gonna do this multiplication inside that bracket, because that bracket's the next innermost parenthesis. So everything else we're gonna write the same for. next to 2, next to positive 15 minus 5, bracket, brace, minus 2. Okay, now what? Well, we got that bracket. We still have to do that, so let's write everything else the same. 4, brace, 2, times this guy, which is just 10.
Oh, that's Mr. Flack, you wrote 2 brace 2.
Oh,
You wrote 4 brace 2.
yeah, it's 4 brace 2. Does that count as a grammatical, mathematical? Yeah, let's do it. Audrey doesn't care. So she did. She went, I don't care. She did. Do you want to do it again on video? No? Okay. All right, and then minus 2. All right, now we got this parenthesis. Let's do that next. So now it's just 4 times 20 minus 2, and then we go home from there. 4 times 20 is 80, minus 2 is 78. Okay, so lots of opportunities for you to mess this up, okay? So make sure you are going slow. And it is, I mean, you could do this in your head. You could check it in your head and make sure it's right. But it's dangerous to do it in your head. That's a dangerous place to do math, okay? So try to get it out of your head, but sometimes when you write it out, there are some rare occasions when it's more confusing when you have to write it out, okay? So I understand that, but do whatever it takes to get this problem right. Whether it's writing it on paper or doing it in your head, whatever you have the most success with, okay? But you have to try both options. Like if you're like, well, I get it right in my head most of the time, well, you might get it right on paper every time. So do that. All right, let's do a little redemption here and then we'll move on to the rest of this lesson. The rest of this lesson isn't anything terribly new. It's mostly just reiterating what we've been doing. So let's see if we can do this one in our head. Why not? Okay, it's kind of a lot to fit in your head, but let's see if we can do it. So I'm looking at, I'm going to do these 2 math problems separately. So it looks like the bottom is going to be negative 3 times 2, which is negative 6. So we're going to be dividing by negative 6, right? Everybody okay with that in your head? Okay. And then inside these braces, there's a bracket times a bracket. You see that? Okay, well, let's do that. Negative 2 minus 3, well, that's negative 2 plus negative 3, which is negative 5, times a negative 2 is a positive 10. So you got negative 3 times positive 10, which is negative 30, divided by negative 6, should be a positive 5. And that's the right answer, okay? So if you can do it in your head and it's not, and it's less confusing, I think this is a doable problem to do in your head, okay? But on a test, it's always nice to show a little work, because if you do, okay, negative 30 divided by negative 6 in your head. All right, so that's positive 6. Write it down. How much of that problem are you going to get wrong? All of it. You're not going to get any partial credit if you just put the wrong answer. But if you put the wrong answer after you did a bunch of that math, and then I see negative 30 divided by negative 6, and you put 6 instead of 5, well, I'm going to give you at least half credit. Well, that's what I do. If I see that you've done something right, then I'll give you half credit. Okay? So that's the beauty of showing your work. It's not just to do math better, it's more math insurance. Okay? So you're showing me that you know how to do this. There's just a little brain fartage, okay? All right. So the rest of this lesson is just talking through some shortcuts, really. We talked about this briefly when we did a problem like this. Well, we didn't really do a product like this, but here's example 3. -4 times -3 times 2 times 5 times 6. Well, how are you going to do this math problem? What are you going to do first? What is that?
Do you put them into groups?
You could, but really, we talked about this little shortcut, not really a shortcut, but it does take away some confusion. Nathan?
Out of the negative, no?
Yeah, just figure out if it's positive or negative first, and then you can just multiply normally, okay? So is this going to be positive or negative? Okay, it's going to be positive. Why? Okay, but what's the rule generally when you're multiplying positive and negative numbers? Yeah. Sorry. What were you going to say?
There's an even amount of
Yep.
negatives.
So if there's an even amount of negatives being multiplied, does it matter how many positives are being multiplied? No. Remember that. Write that down in your brain. Okay? So this is going to be positive, and then you can just multiply normally. What is that? Oh, there's a 10, so that'll come in handy. 12 times 6 is 72, times 10 is 720. Okay? So that's not bad, right? That's a good way to do those. Did I do it wrong? What's wrong? Yeah, you're impressed. I get that a lot. It's okay. Don't be embarrassed. All right. I think we're good. You guys good? So the tricky part, let me just do one more thing, and then we'll be good. So this is example 3C. -3 times -4 times -2 plus 2 times -3. Okay, you guys want to hammer that out? What is it? What'd you say, 38? It's not what I got, but I could have done it wrong. You got 18?
38.
What? What?
30.
30?
I got 30 also.
I
Okay,
got 70.
okay. So I got -30, which is what none of you guys got. So let's see if I'm right. And let's see if I'm wrong, because I could be wrong. All right, so now that rule here, this is not just one big multiplication problem. If it was all multiplication, then you could say, all right, even amount of negatives is positive, odd amount of negatives is negative. Well, these are two separate multiplication problems. All right, so this one's gonna be negative, and then this one's gonna be negative, because there's 3 negatives being multiplied here, and there's 1 negative being multiplied here, okay? So what's 3 times 4 times 2?
24.
24. So it's -24, right? So far so good? And then what's 2 times -3?
-6.
-6 plus -24, -30. Okay, so what did you do wrong? I need to know. I need to know. Nathan.
I did -3 times -4 times -2 plus 2 times -3.
Okay, so you added 2, you just did this order of operations incorrectly, right? So you just did that addition before that multiplication. Got it. All right, what else? How else did you mess this up? Remember, if you haven't heard me say this, it's important to know how to do a problem wrong. It's equally important to know, or it's important to know how to do a problem right. It's equally important to know how to do a problem wrong. Okay, so you know what to look out for. Anyone else want to share their wrongness? Yes.
I just counted up all the negative signs. I was like, oh, 4, it's gonna be
Okay.
positive then.
There you go. All right. Well, that was why I put that problem on that board, because of that reason. Okay. So remember, that rule only works if you're just in the multiplication family. So you can do that rule here and here, but not together. Okay. That's a good mistake. Good one. All right. So let's move on to lesson 14.
Flack math! Give me some math and I'll give you some flack. Flack math!